In this video, we're going to write the equations of lines given an application. So in the first one, we have a salesperson who makes a base salary of $300 a week and then quite a good commission, 12% commission on sales. All right, and we're looking to write the equation of a line using function notation. So the salary of X when X is the number of dollars in sales. And then we'll evaluate that. Okay, so for part one, we're going to use this idea of y equals mx plus b, just remembering that the y is replaceable with a function notation, and in this case, that function is named s for salary. Okay, and so our m, that's going to be our rate, and b is the initial value. So in this case, it's the set salary that is not changing. So that's the initial value there, okay? So S of X is going to be, we have the rate at which they're making money on every dollar of sales, so we would have 0.12x plus that base salary. And there's our function. And now we're supposed to evaluate that when X is $8,000. Okay, so let's figure out their salary when they have sold $8,000. So if we have 0.12 times 8,000 plus that base salary. All right, so we've got 0.12 times 8,000 is 960 plus 300, and that would give us 1,260. All right, so what does that mean? That means the salesperson will make $1,260 in a week if they sell $8,000 in sales. Okay, now this right in here looks a lot like an equation. Okay, a common error is just to want to divide both sides by 8,000 because it really looks like an equation. But this section right in here, this is not it's actually not an equation. This is just telling you what you're being asked to find. Okay, so we have over on the left-hand side, this is showing you what you're trying to find, and on the right-hand side, this is really just an expression that needs to get simplified. Okay, so with function notation, everything looks like an equation, but it's really not. So we don't need to divide by 8,000 there. Just simplify that right-hand side. And this S of 8,000, that is read S of 8,000, and that means evaluate your function, figure out the output when the input is 8,000. So function notation. Let's look at an example where we have cost and revenue. We've got a small business and they make cookies to sell at the farmer's market. The fixed monthly cost for use of a health department approved kitchen and rental space at the farmer's market is $630. So this is a cost to them. And then we have another cost of labor, taxes, and ingredients. For cookies, it's 25 cents per cookie. Okay, and then we are going to make some money here, $7 per dozen. And we need to write a cost function, then we need to write a revenue function, and then we're going to do a profit, and then determine the number of cookies in dozens that must be produced to make some kind of a profit. Okay, and then if we'll figure out what happens if we sell 140 dozen cookies. Wow, that's a lot of baking. All right. Okay, so it looks like we need to be writing a function here for our cost function in terms of dozens. So we want to know how much it costs per dozen. All right, so if we make, let's see, if it costs 25 cents per cookie, then for 12 cookies, there's my dozen, it would cost $3. That's a cost. Okay, for ingredients, etc. All right, so for our cost, we have the $3 per dozen, and then we also have to rent the kitchen. So there's my cost. All right, now my revenue is going to be how much I make. All right, so R of X is the fact that I make $7 for every dozen. Okay, now profit would be you take how much you make, your revenue, and you subtract the cost. And what's left over is hopefully a positive number. Hopefully you're making a profit. So if we're supposed to write a linear function representing profit, all right, so we would take our revenue, 7x, and subtract our cost, which was 3x plus 630. And that would give us the profit function would be 7x, distribute our negative there, minus 3x, minus 630. So the final profit function is 4x minus 630. There we go. All right, so we've got revenue, we've got cost, and profit. So now let's go through and do a little work on analyzing for for D. Determine the number of cookies that must be produced and sold to make some money. So the big idea here, to make money, we want this profit to be bigger than 0. So we would take our profit and make that bigger than 0. The break-even point is when the profit is equal to 0. Okay, but I want my profit to, I want to be making money, so I want my profit to be bigger than 0. All right, so here we go. Put in profit function, which is 4x minus 630. We want that greater than 0, so we'll solve for x here. And we would get 4x is greater than 630. Dividing by 4, we get that x is greater than 157.8. So what does that mean? We need to remember that x is the dozens. Oh, I should write that down. So let x equal the number of dozen cookies. So we need to sell at least 158 dozen cookies to make a profit. We'll just round this up to the nearest dozen. And one more question is, if we sell 140 dozen cookies, whoop, we're not selling enough, are we? Are we going to, or how much money will we make or lose? Well, it looks like we're going to be losing money. So we're going to take our profit and evaluate it when x is 140. So we take p of 140. We take that profit function for x, we're replacing x with 140, and then just calculating out that output. 4 times 140 is 560, minus 630 would give us a negative 70. So when you sell 140 dozen cookies, we'll lose $70. All right. Okay, last one. As we age, stress and worry decrease and happiness increase, according to an analysis of quite a few. It's a pretty good study. And this was an article that was published in Proceedings of the National Academy of Sciences. Okay, so according to this study, we've got 49% of 22-year-olds reported feeling a lot of stress, and then only 29% of 62-year-olds reported feeling a lot of stress. So that the feeling of a lot of stress was going down as the people aged. So we need to write a function, happiness, h of x, that represents the percentage of people experiencing a lot of stress, and x is represented as years after 18. Okay, so we've got 2 data points. We have 49% and we have 22-year-olds. Okay, so let's figure out what the x is for that 22-year-olds. X is years after 18, so let's just find the difference there. And x would be 4 for that data point. Okay, so we've got one data point which is 4 and then 49. The units I'm using for output is just percent of. All right, and then x is years after 18. Okay, so then let's look for our second data point. Here we've got 29% of 62-year-olds. So 29%, and then it's 62 year old, so X would be years after 18. So in this one, X is 44. Okay, so there's our second data point, is when X is 44, our output is 29% of those guys feel a lot of stress. So now if we're trying to write a function for this, we need to take the steps of writing an equation of a line. Number one, find slope. So here we go. Find the slope is the difference in y, so 29 minus 49 over difference in x's, 44 minus 4, and that gives us a negative 20 over 40. So the slope here would be negative 1/2. And now we need to find, the second step is find the y-intercept. There's a little room down here to do that. Okay, so I'm going to use my slope. And then just pick one line. I'll do the first one. It doesn't matter which one, or first point. It doesn't matter which one you use. And I'll use a y of 49. Okay, and then we'll figure out our y-intercept. So using y equals mx plus b. And our y is 49. Our m is 1/2. Oop, negative. Negative. Okay, and then our x is 4. And then we'll solve for b. So we've got 49 is equal to negative 2 plus b, and then add 2 to both sides. b is 51, and we'll explain what this means since we're right here. Okay, so y-intercept, the y-intercept is 0, 51. That's the initial value, and remember x equals 0 would represent 18 years old. So 18-year-olds reported feeling 51% of 18-year-olds reported feeling a lot of stress. Now we're trying to write the equation of a line. I'm kind of skipping around, sorry about that. So number 2 we just did, find the y-intercept. Find y-intercept, we just got that, so b is 51, and now we're ready to write the equation. Okay, so, oh, it's h. So h of x is equal to negative 1/2 x plus 51. There's our function. And now use our model to predict the percent of 30-year-olds who experience a lot of stress. So we need to put that in terms of x. So a 30-year-old, x would be the difference between that and 18. Okay, so x would be 12, and then we're going to go in and evaluate our function with an input of 12. So h of 12, there's me showing what I'm being asked to do, and now this isn't actually an equation. What I need to do next is plug in that value of 12 for x and just simply simplify this expression. Okay, so not an equation. We don't need to divide both sides by 12. Just simplify the right-hand side. Negative 1/2 times 12 is negative 6, plus 51 would be 45. So 30-year-olds are still experiencing quite a bit of stress. 45% of 30-year-olds would, according to this study, be reporting feeling a lot of stress. But just wait. As you get older, that will decrease. We hope.